Hello viewers, I'm Kausalya. Today we are going to solve problems related to AC parallel circuits. The problem is a 100 ohm resistor and zero point 0.6 Henry inductor are connected in parallel across the 250 volt 50 Hz supply. So here we are having a R and an L and they are connected parallel across this voltage source, right? So find the line current, impedance, power dissipated and parameters of the equivalent series circuit, right? So here we are going to design an equivalent series circuit, right? And the parameters included, what are all the elements present in a series circuit, we have to calculate its value. Apart from that, we need to calculate this current, impedance and power dissipated, right? So this is the diagram, right? R and L are in series and we are having a voltage source. So here, what are all the given data? The value of resistor is given, it is 100 ohm and the value of inductance is 0.6 Henry. Voltage and frequency are given. So here the first step is we are calculating XL. So XL is given by J 2 pi FL, right? So here if it is XC, then we have to use minus J, right? So it is, since it is XL, here we are including J alone. So we know 2 pi, we know F, what we know L, just substitute, okay, and write the thing in polar form. And the next thing is these two, that is R and L, are in parallel, right? Therefore, the equivalent impedance is, you see, Z1 is parallel with Z2. Therefore, Z1, Z2 divided by Z1 plus Z2. So what is Z1? Here the value of resistance is simply 100, right? How to represent this in polar form? 100 with an angle of 0 degrees, right? So therefore, just substitute the values here. So in polar form, we can directly, we can multiply and here comes the answer. And we can't add or subtract in polar form. So we are converting this into rectangular coordinates, right? So finally, here the value of impedance is given as 78 plus J 41.46. Now we are going to find the parameters of the equivalent series circuit, right? That is, if the given diagram, okay, if the given problem is modified into a series circuit, how it will be. So as usual, we have calculated the value of impedance, right? So 2 pi FL is equal to 41.46, right? So from this we are going to calculate L. So just calculate L, the value is 132 millihenry. And the next thing is we are going to calculate the line current. So current is given by V by I. So here it is V by Z. We know V, we know Z. So just substitute the values and calculate the current. Apart from that, we need to calculate the power dissipated. So power is given by the formula I square R, right? So we know the value of I, we know the value of R, right? The value of R is, how to calculate the R here? You see, the value of Z is calculated as 78 plus J 41.46. This means that this is R plus J XL, right? Only from this expression we are taking the value of XL as well as we are taking the value of R, right? So just substitute and here the value is 527 watts. Or else we can use the formula VI cos pi, right? We know V, we know I and we know the angle also, 28 degrees. So just we can substitute and finally you see the answer seems to be the same here, right? So here comes the end of this problem. We will proceed with the next one. The problem is a voltmeter connected across the 5 ohm resistor in the figure reads 45 volts. Find the current I. So here this is the given circuit diagram. The voltage across this resistor is 45 volt, right? And the remaining parameters, the remaining values are given here. So we need to calculate the total current I. So how to calculate the current I here? I is nothing but I1 plus I2, right? So the first thing is, it is very easy to calculate I1. Do you accept or not? You see here we are having 45 volt, that is voltage across this 5 ohm resistor is 45 volt. Then how to calculate current? I is nothing but V by R. So 45 by 5 gives the value of I1, it is nothing but 9 amps. Right? I1 is calculated easily. So when you represent I1 in polar form, it is 9 with an angle of 0 degrees. So from the diagram, you see that is J6 and J3 are parallel. So how to calculate the total equivalent value? Z1 into Z2 divided by Z1 plus Z2, right? So just calculate here, minus J into minus J is equal, J into J is equal to minus 1. Therefore, minus 18 here. Here we have added, so J9, right? So when you cancel each other, here comes 2. So minus 2 by J. Again, when you move this J to the numerator part, it becomes minus J. Therefore, here the answer is 2J, right? So when you look back at the problem, we have eliminated these two inductors with a single inductor here, and its value is 2J, right? So here there is a 2J in series with this 5 ohm. So what about the value of R? That is the value of impedance in that branch. So it is 5 plus 2J, right? The next thing is voltage across AB. So you see, this is your A and this is your B. Voltage across AB means this entire part, right? So voltage across AB is nothing but I into R here. So the current flowing through this branch is I1. So I1 into the value of R is 5 plus J2, right? So the current I1 it is given as, we have already calculated, right? It is 9. So just substitute and here we are getting the answer, right? So voltage across AB, again when you look back, that is voltage across AB is this, right? So this voltage will be impressed across this branch also, because these two are in parallel, right? So voltage across this branch is equal to voltage across this branch, right? So here I2 is easily calculated, right? Because we know the value of voltage. So V by Z, so the V is 45 plus J18 and the value of impedance is 3 plus J4, right? So again when you solve these equations, these values, finally we are ending up with the answer as 8.28 minus J 5.04 amps, right? So here the main aim is to calculate the total current. So total current is nothing but I1 plus I2. So just add, we know I1, okay, just now we have calculated I2, so just add, and finally the total current is calculated as 17.28 minus J 5.04 amps, right? So here comes the end of this problem. We will move with the next one. So the problem is, in the arrangement shown, calculate the impedance between A and B and the phase angle between voltage and current. When the voltage between A and B is 100 with an angle of 0 degree volts, find the current through the capacitor. So here this is our given problem, right? So again we need to calculate the impedance, okay? Impedance between A and B, and the value of the voltage is given. Again we need to calculate the current flowing through this capacitor also. So the first task is, we are starting with finding impedance, right? So again this branch is parallel to this branch. So how to express this? You see here it is, everything is represented in ohms, right? So R and the value of this is XL, right? So while representing impedance for this branch, you have to write it as 8 plus J10, right? So 8 plus J10 is parallel to 7 plus J9. So that is our first step. So as usual, the formula is Z1 into Z2 divided by Z1 plus Z2, right? So here just substitute the values, and finally we are ending up with the answer as 6.03 with an angle of 51.8 degrees, right? Now we have solved this part, right? So the value of this parallel impedance is 3.73 plus J 4.74 ohms, right? Now this ZP is in series with J2 ohm and 5 ohm, right? So here you see, now this is resolved into a single combination, and that combination is in series with this part, right? So again the total impedance is given as, since it is a capacitor, here we are including minus j2, okay, plus 5. So we know the value of this part, so just substitute it here, and the final answer is 9.15 with an angle of 17.4 degrees. So here the value of pi is 17.4, right? And the value of this ZAB is 9.15. So the formula to calculate current is V by Z. Okay, we know V, we know the value of Z. So just substitute and find the value of current here. So this is the value of total current, right? So the same current flows through the capacitor, you see. So here flows some current I, right? This current gets divided into two different types, that is I1 and I2. Again, when you come over here, again these two currents get added together, and finally here we will be having our I, right? So the current that flows through the capacitor is same as the current that flows through, that is the total current that flows through the circuit, right? That is why here current flowing through the circuit is equal to current through the capacitor, right? So here the answer is 10.93 with an angle of minus 17.4 degrees. So here comes the end of this problem as well as the end part of this video. If you have any doubt, let me know in the comment section. Thank you.